everybody, and welcome to our very first Little Horse talk show. I'm Sohini, your developer advocate straight from Little Horse, and we're going to have a lot of fun conversation today with our very first guest, who's the founder of Little Horse. Let's welcome Colt McNeely, and here he is.
Well, quite an introduction. Thanks, Sohini. Great to be here. First time we're actually doing some form of a live coffee chat, and I think
Yep.
someone volunteered me to do a live demo, but thankfully I didn't write the code for this demo. So a quick shout out to Mihail, one of our currently our newest member of the technical staff.
Yep.
He made a cool application, which maybe if we have time, I'll get to show you guys.
Yep. We'll get to there till the end of our session today. So be excited and stay on our chats. So hello to all the people who have joined us today, and I just want to say stay tuned on our chats. Please feel free to ask questions, and if you're here online and watching us live from wherever you are, just hit a hi on the chat so that we can tell you hi too, and we can all talk together as we go ahead. All right. So today's topic is quite interesting, and I would like Cole to tell us a bit more about what is the agenda today and what we're going to talk about and how the session is going to go.
Yeah,
Over to
so
you.
I'm just going to chat a little bit about the origin story of LittleHorse, why we decided to start it, why we think it's going to be an impactful venture, and how we want to change the way software is written in the future.
Yep, that's right. So, but before we get into that, like the very first question that comes to my mind is, why Little Horse? Like, what was the reason you decided to do Little Horse in the first place?
Why LittleHorse? So going back a long time ago, back when I was younger, I was a software engineer at another company, and they're a real estate startup, and I was involved in this project called ScheduleBot. The purpose of this project was to schedule home inspections, showings, consultations, open houses, and stuff like that. But it was pretty complicated because there were different people that you had to coordinate. There were agents, there were inspectors, the buyer, the
Yeah.
seller of the house, and people could cancel, schedules didn't match up. And to make matters worse, we were using many different third-party APIs, some of which went down at random times. Additionally, we had a lot of problems with unreliable microservices that were even managed by our own systems, because we were kind of new to the microservice architecture, and we got a couple of things wrong. But it was a supposedly simple application that really shouldn't take that long, and it had a real business purpose, but it just took a lot longer than it should have to deliver, and there were too many bugs. Adding new features took too long, and generally the developers working on that project were not really happy. And we like happy developers. Happy developers produce good code very quickly, and good code produced quickly is good for your business and your bottom line. So I thought, you know what? Well, why don't we start a company that would make it easier to solve some of these problems? And we'll get into those problems later over the course of this discussion,
Mm-hmm.
hopefully.
Yeah, I get it. But the reasons that you said and the problems that you said that, the problems that made you think that there should be a little horse is something that we often see even today. Like, even when I speak to many people, they would say that this is the biggest problem today. So, yeah, definitely it makes sense. All right. So, I have one more question to you. Oh, and before I go ahead and shoot that question to you, actually, we've spoken so many times, but I never knew. Uh, that why you started Little Horse. So I think it's good that I know it now.
I probably should have started with that when you joined, actually.
Yeah, that's
Yeah.
right.
I
Okay.
started it because of some rather nightmarish experiences trying to build software at a previous company, and I want to prevent other developers from having to go through that nightmarish experience ever again. So
Yeah,
that's
but
basically why we started LittleHorse. We like happy
and
developers.
like when you actually have a real reason that you've faced, and you've seen other people facing it, and you've felt it yourself, and then you create a solution, you build a solution, and that's much better than actually just thinking about something and starting to work on it. Because when you feel it, you know it, like how you can just make it work, right?
Yeah.
So yeah. Okay. Now I have the next question for you, which I was gonna ask. So, like, how do you think that microservices allow organizations to take advantage of the cloud's elasticity? And
Uh,
like
so
what according
that's
to
a good question. That's a good question. Like
yep,
elasticity is one thing. I mean, back in the 90s, I was born in the 90s, actually. I'm not that young. But I don't
me
know
too.
this. I'm just hearing stories about it. Back in the 90s, people used to buy a server and put it under the desk and run their entire business on that server, which doesn't really scale anymore these days. I think microservices solve a couple things. They have a couple main benefits. And the first one is one you already touched on, which is elasticity. And what that means is that you can easily scale up and scale down. It's very easy to deploy microservices on an environment like AWS, for example, especially using their serverless functions or Kubernetes or perhaps their ECS services. So it just makes it very easy to take advantage of the economies of scale in the cloud. And also, you don't have to buy, running on the cloud is a lot easier with microservices, and the economics of cloud are much better for startups, especially. The other reason is when you have a large engineering organization, for example, Facebook has a couple thousand engineers.
Yeah,
Microservices tend to make it possible to split up the core functionality of whatever the backend services of Facebook are into multiple different teams, because that way one team is responsible for deploying their component of Facebook, which is many different things behind the hood, under the hood. One team is responsible for deploying their individual part of it, and they can make updates to it separately. They can use their own technical stack. That way they don't have to coordinate across the team. So
yeah,
microservices really become very useful when you have enough developers that you can't coordinate them all on one team. At that point, then you want to start breaking it in microservices. I know if you read Twitter-driven development, which is a new type of development I've found out. There's all of this pushback against microservices, and sometimes that happens when you have one team managing like 6 or 7 different services. And to me, that doesn't make too much sense, because you probably want to, one team should be able to coordinate well enough. You don't necessarily need to have 6 or 7 different deployables for just one team. So that might be
right.
premature microservicization, if that's a word. But the two main benefits, in my opinion, are microservices enable you to more easily deploy stuff to the cloud, and different teams can iterate independently on different components of the software.
Yeah, that makes sense. And, that is also generally something that happens in, most of the organizations, especially the bigger companies. Because in startups, I think the scenario is quite different. But in bigger companies, I think it's just a team managing 6 to 7 microservices altogether. And yeah, totally makes sense. Okay, cool. So I think we can move on to the next question, which is again, like since you spoke about the advantages, I would like to learn about some of the major tech challenges that you can see, um, with microservices. And
Okay.
also, before you answer that, I would also like our audience to help us learn some of the challenges they face. So here's a question for you all too. What are some of the challenges that you think occurred because of microservices, especially in your own organization? I'll wait for the answer. Yep, go
All
on.
right. So there's a couple of challenges with microservices, and then there's some challenges that kind of existed before them. But I'll stick specifically to microservices. So when you have different services and different containerized deployments, or maybe even serverless deployments of software applications that are supposed to coordinate together to implement one end-to-end business process, there's a lot of coordination challenges that arise from it. First of all, you have a distributed system now, and when you have distributed systems, there's all sorts of challenges, like the network can fail, servers can crash, and you have to, in the current day, you have to spend a lot of time worrying about um, reliability. So the first problem being reliability. You see engineers spending time writing retries and dead letter queues and timeouts and re-implementing these same patterns over and over again, or the transactional outbox pattern, a Saga pattern. And those patterns get implemented over and over and over again. They're hard to get right. So sometimes you push buggy code that will not work. They're not really fun to do. And it prevents you from shipping a really cool feature quickly, which makes the product managers angry, and angry product managers mean unhappy developers. So we don't like that. What we would like is we'd like to have one solution which would make, give you retries, timeouts, and dead letter queues out of the box, or the equivalent functionality, and also make it really easy to implement more complex patterns like Saga or the transactional outbox, which are used for atomic updates across different services. So the first problem being reliability. I think the second problem with microservices, and this is also even true with some more legacy applications, but not as much, is traceability and observability. Now, you have different services managed potentially by different teams, hopefully managed by different teams. Otherwise, you have premature optimization that are communicating with each other in more large organizations. And now you have to keep track of, well, who's consuming my API? If I want to change this API in a breaking manner, what teams do I have to connect to, right? Mm-hmm. How does this business workflow of someone actually clicking checkout on the Amazon shopping cart, and then a couple days later, a package showing up at their door, what goes on behind the scenes? Which services are involved with that? What teams do I need to talk to if I want to change that? That becomes really, really hard to answer. And then the third problem is modeling complicated and modeling or changing rather complex processes, especially those that involve time. So if there's anything that does something like, when event A happens, wait 30 minutes and then check for something and send a reminder perhaps. Or a real world example of this might be someone puts an item in their shopping cart on Amazon or whatever e-commerce site it might be. And then 30 minutes later, you want to send them a reminder to tell them that, hey, are you gonna check out of the shop? Are you gonna check out your shopping cart or not, right? That's actually a little bit harder than you would think to implement, even in a legacy world, and even in a modern world. With microservices, it becomes even harder, right? And things like changing the way the checkout process works. So, for example, you might want to insert a verification step to verify, that this is not a bot, right? And modeling that, as Soul says, modeling that using choreography could be quite difficult. And using an orchestration engine, such as LittleHorse, makes this a lot easier, because now the business logic for what needs to happen when lives in one central place. You can change it by changing the workflow, and then all of the workers or microservices that connect to LittleHorse, or all the different microservices, just have to do one thing very, very well, and the workflow will tell them when to do what.
So from what I understood is, if you have all these workflows designed properly, then these microservices can be handled in a lot easier way, right?
Exactly.
It can solve the challenges. Okay, got it.
The goal.
Wow.
One goal is, instead of developing tech debt every time you add a new feature, you want to develop a new library of reusable and composable pieces that can be dropped into many different business flows. That's the goal of LittleHorse.
That's right. That's going to reduce a lot of time put on it and a lot of efforts. Absolutely. So, like, from all the things that you have said, I've understood two things: is that we're super friendly for developers, because we're trying to give them a good development experience, and also we're trying to solve all these problems that are related to microservices to a very, very large extent. Although I didn't understand what spider webs are. Is that a particular thing in tech, or is that a word that you used to refer to the complex microservices working all together?
Well, we like to use internally the words spaghetti architecture or spiderweb architecture when we're describing some things we've seen in the field with some early prospects, or actually what I saw what we all saw in our previous jobs, actually. Where you have different pieces of software firing RPC calls at each other across the net, sharing state in the database, too many Kafka topics, too many Kinesis queues, too many SQS queues with no coordination. And there's just a big mess of stuff happening, and it's cacophonous, and no one has any idea what's going on. That's the spiderweb architecture.
Got it. All right. That's cool. I think that's a lot of, that's a great discussion on this question, actually. And we've also got Mihail responded to it. He says that connect or trigger events on state change between microservices is painful. I think that is one of the other challenges.
Yes, that is true. I mean, I guess I could show a demo for that if you'd like, but I'd have to fire up a new one, which might take a bit too much time.
Okay,
So I
maybe,
think what
yeah.
Mikhail's referring to is there's often this pattern of one service doing something and other people
Mm-hmm.
caring about that service doing that thing. So for example, there might be an order processing microservice which processes an order, and then there might be a revenue forecasting service which cares about the amount of orders that were forecasted, right? So if you want to have any sort of real-time revenue forecasting dashboard and you don't want cron jobs, this might want to be the best example, because using a cron job is not the worst thing for this, because it's just metrics reporting. But if you
Mm-hmm.
want to have some sort of real-time forecasting, you need to have an event fired somewhere that will notify
Okay.
the revenue forecasting service that an order was just placed, so that it can update its models or whatever. And what people do oftentimes is they will use some form of what's called change data capture, or CDC, where
Yeah.
the order service will make a write into a database, which is used internally, and then there's a CDC system which broadcasts that change in the database elsewhere. There's a couple problems with this. Number one is that the database is kind of an internal implementation detail of the order service, and then we have other systems becoming tightly coupled to that schema, which is not good, because then if the order processing
Mm-hmm.
team wants to change their schema or migrate to a different database, everything else breaks.
It's gonna,
Um,
yeah, it's gonna crash. Mm-hmm.
yeah, so that's one problem, is this event triggering kind of thing, and then also CDC is difficult. Okay.
Yeah. And then we've got this one last one that we've got from Saul. He says that one quite challenging problem I faced at a previous job was auth. Is that the right way to say it? Oddsy, which services have what permissions, and even worse, how to configure that. Okay.
Yeah, that's a hard problem.
Yeah, yeah.
So LittleHorse is
And
not
I'm
an
sure.
authentication solution, but we do have some authentication built in. I mean, in
Okay.
terms of microservice authorization and authentication, there's a lot of cool solutions out there
Mhm.
like Istio, which we're using internally for
Yeah.
LittleHorse Cloud. But
Okay.
LittleHorse does have a couple cool features about that. I mean, now that I'm talking about LittleHorse, I might as well brag about some of the work that Edward did. Um,
Absolutely. Please go on.
yeah,
I'm
so one
all
of our things,
yours. Yeah.
he added ACLs to the LittleHorse server. So now when you have different
What's that?
workers or microservices
Uh-huh.
connected to LittleHorse, you can limit their abilities to only do exactly what they need to be able to do. So for example, one task worker that is responsible for sending a push notification to a customer's mobile app only can execute that task. That's the only request it's allowed to make to the LittleHorse server. And you can do this
Okay.
by configuring ACLs in LittleHorse. You'll soon be able to do that with the CRD or via the LittleHorse Cloud Console by clicking and dragging if you're using LittleHorse Platform or LittleHorse Cloud, respectively. But for now, on LittleHorse Open Source, this feature is available in early access, and you can use LHCTL to manage your principals.
Do you hear that, friends? Go and check out ACLs on LittleHorse quickly.
Well,
Cool.
not too quickly, because it's still in early access.
But still, we can all have you on the wait list so that y'all could be the first ones to get the first few accesses. So
Cool.
it's gonna
Sounds
be
good.
cool. Yeah. Okay. Cool. So I have one last question, and then we can do something interesting. So, like you've spoken about the like advantages of how microservices can allow organizations to take advantage of the cloud's elasticity. And then we've
Mhm.
spoken about some of the major tech challenges that we have faced, and some of our audience and all the people out there would face with microservices. So now, since we talk about Little Horse, let us also learn about how um, workflow engines like Little Horse solve all these challenges.
Well, that's
So
a
could you
tall
tell us
ask.
a little more?
And that's a tall ask, but we'll try. Uh,
Okay.
and you
Okay.
framed that perfectly. Thank you, Sohini. So, how does LittleHorse address some of these problems? Well, the three problems I mentioned about the modern, the difficulties that you'll face in modern applications, and Saul added a fourth, which was a difficult
Mhm.
one. But the first three I'll focus on.
Okay.
We have number one, reliability in the face of a distributed system. Number two, we have traceability, and then number three, we have managing the business logic and the business process. Right. There were workflow engines in the 1990s that kind of solved these problems, but the problem is they all ran on a single server, and if that server crashed, then your whole business came to a halt, or and also, wasn't very scalable. You definitely couldn't run Uber on one server. So how does a workflow engine help? With reliability, the workflow engine itself needs to be, persistent. It needs to be able to persist state in a durable manner, so that if the workflow engine crashes, then, or if a server on the workflow engine crashes, there's still other servers that have that data and continue processing workflows in real time. And LittleHorse has that, right? But that's not enough, because now you need the workflow engine to be able to keep your applications running. And we also do have that by having built-in configurable retry capabilities, with also timeouts, and then advanced exception and error handling capabilities, so that you can define what happens if something goes wrong at a technical level. We call that an error. If, for example, a server crashes or a task worker doesn't respond in a certain amount of time. And what happens if there's a business process level, for example, a credit card runs out of funds. All of those error handling capabilities all of those error handling scenarios are made much easier with a workflow engine like LittleHorse. The second one is traceability. I can show you really quickly, if you have time, to give a quick demo at the end.
Yep, sure.
There is an observability dashboard that will show you in real time all of the exact status of every single workflow and every single step that's been executed, the inputs and the outputs, allowing you to quickly and easily debug your systems. And then the last one is coordination and changing the business flow, changing your software to meet new business practices. That is quite easy with LittleHorse compared to without a central orchestrator, because you have in the center of your system one place where you can put the workflow. You can define the step of what needs to happen, what microservice needs to call to do what at what point, depending on what conditions. And then you don't need to dig through the code of 10 different microservices in order to figure out who's calling what at what point. Rather, everything lives in one spot, and you can easily, you can very easily change it by just updating the workflow specification.
Yeah, and I've actually tested that out. And actually, to all the people watching us live here today, if you also want to learn about some of these demos and how actually some of these things work out, there are some pretty cool tutorials on our YouTube channel. You can go watch those. We've got playlists for beginners. Some of them are quite a few advanced concepts of LittleHorse. So definitely go check those out, because you're going to get a good idea of how workflows work. Workflow engines work at LittleHorse, and what is a workflow specification, and all of the other things that we're talking about. Well, y'all can do that, but before, so we're quite running towards the end of our show today. And before we end it, I would have my last ask for you, Colt. And that is, if you can show us a quick demo of all the awesome things that we spoke about, because I would love to learn and watch out a demo. So
awesome. Sure. Before we do that, I'd like to highlight again. It's fine. You can share the screen. I'd like to highlight again those videos that Sohini was talking about. One of them was a collaboration with Sohini and Mihail. And I mentioned earlier CDC and the transactional outbox and the Saga pattern. And there's one video which explains how those patterns kind of work, why they're necessary in the real world. And then also we have a demo of how you can implement those patterns using LittleHorse, and Sohini and Mihail walk you through it very easily. That code's open source. We can put a link to it in the comments afterwards. And the video is fantastic. Highly recommend you guys check it out. Okay, so I don't have too much time to go through this, but here is a relatively complicated workflow specification that is intended to show how how a KYC functionality might work with LittleHorse. And basically, when someone initiates a flow, we're going to ask them to submit a passport, wait for them to submit a passport, and already we have two different LittleHorse capabilities here. First one is oh wait, we already have the link in the show notes.
Is it possible for you to zoom it a bit? Probably.
Okay, I can zoom in. Yes. So the first thing we do is ask the user to request to submit their passport. Then what we do is we wait for them to submit their passport. So the first node is a task. This is one piece of functionality where we actually send work to a LittleHorse task worker, and they're listening on a task queue, and then they execute some work, which is generally a Java, Go, or Python function. The second thing is called an external event, where we wait for a callback to come in, which comes in when a human submits a passport. So then we, use a dummy AI task. This is just a demo; it's not real AI, but we process a passport, and depending on whether it's determined to be legit or not, if it's valid, or if it's not valid, or if it's valid, we'll either request manual verification, which is a user task to be executed by a human, or we'll just automatically verify the user. And I can show you the code here. The code is, I need to update my Visual Studio Code apparently. Here is the code that kind of walks through that workflow, and you can see it's in Golang. You can define workflows in Java, Go, or Python. This code is, basically we just declare a couple of variables, we execute the first task, we wait for the external event right here. We save the content of the external event into a variable, execute some more tasks, and then do some conditional branching based on whether or not the AI determines the passport to be valid or not. So I'm showing you this because I want to explain kind of how LittleHorse works at a low level. So we see this dashboard right here, which shows the workflow specification. The workflow specification is a metadata object that lives on the LittleHorse server. So this defines all of the various services and how they talk to each other. So one is something that sends a notification to a customer and says, hey, send us your passport. Another one talks to some AI API that processes the passport. Another one, talks to the database and creates the customer, right? Yeah. It's a little bit, there's a lot of moving parts here. But this workflow definition is the central orchestration thing that I was talking about, and it lives on the LittleHorse server. It's defined by this code, and this code is the LittleHorse SDK, which translates it into a workflow specification, which you'll see right here. So the name of the workflow spec is KYC. We're going to print it out. We can see that code got translated into this protobuf object, which is printed as JSON here. And this metadata object gets thrown at the LittleHorse server, and that defines how the workflow works. I don't see any questions right now, so I will continue, which may be risky, but.
Yep. Yeah, no, you can continue.
Okay, so we'll run the thing here. McNeely is me, Colt at LittleHorse.
So what's this like? So you're logging into this. So this is kind of a portal.
This is a portal, which is part of the demo.
Okay.
And the code is available online. We can put a link to it afterwards. But when what's going to happen is when I submit this form, it's going to run the workflow. And then we'll see that right there, right? So I'll create the account, and it says user created, please check the email. All right. So if I refresh the page and I scroll down here, we can see my running workflow instance, right? So this is the observability thing I was talking about. We can see the workflows right here. It's waiting for the passport to be submitted. And this is the value. If you look at the workflow, we can see the value of all the variables that we define. So first, the user is this thing, right? Colt McNeely, right? That was the input to the workflow. And the passport is null right now because I haven't submitted the passport. And if you look back at the workflow, you can see where that comes from. Here's the user and there's the passport. So anyways, I got an email and it looks like spam, but it's not, I promise. Please submit your passport to proceed with the verification, and then I will go up here, right? So here is whatever it is. I'm going to, upload anything. Upload the passport, and I marked it as not fraud. So we should see the workflow when I refresh the page go down here. And what happens when we do? Well, the workflow has now moved on, and it was detected as not fraudulent, and the customer has been created in the database. So we can see
this is for like
so on and so forth.
So like the verification got processed, right? So you just uploaded and that got processed, and that's the reason it came down to that node, right?
Exactly.
Okay.
Yeah, exactly. So that's a demonstration of the LittleHorse, that's how LittleHorse kind of works, and you can kind of see how it solves all these problems. Now, we didn't really
Yeah.
show some of the reliability features here. Like, everything worked, which was nice. But, in the real world,
Mm-hmm.
sometimes uh, this, the user might not submit the passport in time, in which case we have to send them a reminder or fail a workflow. We can handle that. If
Yeah.
processing the passport fails, we have retries, we
Mm-hmm.
have exponential backoff. And then we can, if you really want to, you can configure an exception handler in case, sorry, an error handler in case the retries get exhausted and the API is still down. But this is just kind of
Mm-hmm.
a happy path demonstration of
Yeah,
how
it's more like an overview of how this thing actually works out. And
exactly.
definitely we could do all these deep dives or, more of a real life example somewhat in the near future. We could do some more series together where we could talk about a little more in-depth videos, um, demos that talk about all of these. And that's something that we're definitely going to do. But
Awesome.
yeah, like I think it was nice to actually get a great overview of how this thing works out, and of course to learn about LittleHorse. And then what was more interesting was we started from the challenges, and then we learned about how to solve those challenges, and then we learned about how LittleHorse solves these challenges. So that's definitely very much informative and insightful. So thanks for doing that, Colt, and thanks for all the information and knowledge that you have shared with us today. So I think we're here and we're almost by the end of our show today, and we're definitely going to come back for one more show, one more episode, and a few more episodes after that. And what would be really interesting is that all of you come and ask us more questions. You can comment below and ask us about anything and everything that you want to know. It's going to be absolutely interesting. And about the session today, about all the things that we've spoken about, we're going to attach the links to all those important things we spoke about to the comment, and so that you all can have access to it by the end of the stream. So stay tuned for that. So before we drop out, is there anything else that you want to share, Colt? Anything before we leave?
Well, I wanted to say thank you for hosting Sohini, and also everyone, please check out Sohini's transactional lockbox video, and also the IT
Absolutely.
incident management one, where she has a full series and she goes into how do you actually write the code to do some of this in Java. So highly recommend you check those out.
Yeah.
And thanks for joining.
Thanks for that, Cole. Thanks so much for letting the people know about it. And I think the IT incident management series is more about a real life problem. It covers some of the scenarios, and definitely, it's something that you can learn more about. There's a lot in there, and we have everything attached to its description and comments. So definitely go, and do not forget to subscribe to our YouTube channel. Do like and share all of our videos and spread the word with your friends. We really are happy and thankful that you've joined us today for our session. We're going to come back with one more session soon, and we'll let you know. So I think, yeah, that's all. Thanks for joining in.
Thank you.
Bye.